Hello everyone. So in this lecture we will see concept of linear programming formulation. So we will see this concept of linear programming problem with the help of this example. In this example, a small scale industry manufactures two types of products. First is P and second is Q, which are processed in a machine shop and assembly shop. Product P requires 2 hours of work in a machine shop and 4 hours of work in an assembly shop to manufacture, while product Q requires 3 hours for machine shop and 2 hours for assembly shop in one day. The industry cannot use more than 16 hours of machine shop and 22 hours for assembly shop, and it earns a profit of rupees 3 per unit for product P and 4 per unit for product Q, and give the mathematical formulation of the problem so as to maximize profit. So first we will write this problem in tabular form. So we will focus on two things. First is basically input and second is output. So in input part we will see two things. First is machine shop and second is assembly shop, and final product P and Q, and with their profit of 3 rupees and 4 rupees. And P requires 2 hours on machine shop, 4 hours on assembly shop, and profit on this P is 3. And for Q, machine shop requires 3 hours, assembly shop requires 2 hours, and profit of rupees 4. And total availability of machine shop is 16 hours availability of machine shop, and total maximum availability of assembly shop is 22 hours. So this side is basically output side, final product P and Q, and this is input. We can say this is resources also, input. So we need to construct linear programming or formulation of linear programming. And in linear programming there are three parts. First is objective function, second is subject to constraint, and third is non-negative constraint. So first we will consider the quantity. Let the quantity for P is X. We are producing X quantity for P and Y quantity for Q. This is the first thing. And now objective function. As this case is associated with profit, and profit should be maximum. Sometimes this may be cost, so cost should be minimum, and if this is time, then time should be minimum, revenue should be maximum. So we can decide this is the case of maximization or minimization. In this case already given, this is maximization of profit. So for profit in objective function, first we will write Z. Z represent profit, and this is profit, so profit should be maximum. So that's why we will write maximum Z, max Z. Now we are producing X quantity for product P, and per unit profit for product P is 3 rupees. So 3, we are producing X quantity, 3 is profit per unit. So total profit for this product P is 3 into X. 3 is rupees and X is quantity. So profit from product P is 3x. In same way we can find profit from Q. So we are producing Y quantity and 4 profit. So for Y quantity, profit is 4y. So this is 4y. So this is considered as objective function. Maximum Z, maximum profit equals to 3x plus 4y. Now subject to constraint. Subject to constraint is based on input. We can say raw material or resources. So in this case machine shop considered as machine shop and assembly shop considered as resources, and resources should be minimum. So in this case 2 hours for product first, and we are producing X product. So 2 into X requirement for X product, and for second product Q, quantity is Y and 3 machine hours. So for by number of product, machine hours, total machine hours, machine shop hours is 3y. So for product P and Q, total machine hours required 2x plus 3y, and maximum availability of machine shop hours is 16. And this is maximum availability 16. This means you can utilize exactly 16 or less than 16, but not more than 16. So we will write this as less than equals to 16. If availability of time is 16 hours, then you can maximum utilize 16 hours or less than 16. So this is the first constraint for machine shop. In that way, we will prepare constraint for assembly shop. So 4 into x assembly hours for product P, and total assembly hours for second product is 2 into y, because 2 hours for one product and we are producing y product, so 2 into y, and total availability of these hours is 22. This is maximum availability, that's why we are using less than or equals to, because we can use maximum 22 or less than 22, but not more than 22. Now, as we are producing two products x and y, third constraint is non-negative constraint. When you will produce any quantity, so at least you will prepare no quantity, this means 0 or 1 or 2, but not in negative terms. You will not prepare -1, you will not prepare -2. So these values of x and y always greater than or equals to 0. These values are always positive. So these three things considered as LPP. This complete formulation is considered as formulation of LPP. So I hope you understand this concept. So in next part we will discuss how to solve these problems. This means how we will find value of x and value of y. So please like this video and subscribe my channel Ganit Coach. Have a nice day. Thank you.